You've already learned about qualitative and quantitative variables. Specifically, the qualitative variables are non-numeric and quantitative variables are numeric. This lesson will concentrate on how we organize qualitative variables so that you have a better view of the meaning of whatever data that you're given. You'll see here, it looks like we have a table of data, which is about political party affiliation. Just to give this some context, just assume for argument's sake that I asked one of my classes that has 40 students in it what their political party affiliation is, and this was the result of it. You'll see that this entire grouping looks like we have 8 rows and 5 columns, so that means there's a total of 40 in the actual graphic right here. So how exactly do we organize this data, which is clearly qualitative in nature? We use something called a frequency distribution table, generally called frequency distribution. This table that we develop is basically going to list out all the possible outcomes. So in this case, that would be Democrat, Republican, and other. And it's going to quantify how many of those results we end up with. So we'll call this PPA for political party affiliation. And over here, we're going to put frequency. The best way to define frequency is it's basically a count. So what we need to do is we need to, just as it says, we need to count out how many there are of each one of these outcomes. So I'm not going to sit here and, tally them out right now, but if you do on your own, feel free to pause the video. Then what's going to end up happening is you will end up with 13 Democrats, 18 Republicans, and 9 other. Believe it or not, that is a frequency distribution. Very simple, very straightforward. The idea is it gives us an idea of how each one of the outcomes, how many of each one of the outcomes occurs, so we can compare them to each other. It is a great way to organize data that is just thrown at you so that it appears better, basically. One thing to note, when you're done with your frequency distribution, you always want to do a little bit of a check. What do I mean by that? You always want to sum up this column. You can see this is 13, 18, which is going to be 31, plus 9 is going to give you 40. The reason why you do that is because you basically just want to verify that you have a total that is consistent with our result over here, our 40. We want to make sure that all is good with that. If you end up getting 39 or 41, then obviously you made a mistake somewhere. You want to make sure you have the most accurate result you can, obviously. We also have one more way to organize qualitative data. Besides a frequency distribution, there's also something called a relative frequency distribution. Okay, this is set up in a very similar manner. We're going to have the same table to start. So political party affiliation, we got Democrat. Let's do a little bit of a abbreviation here, other quicken things. But on this side, we're going to have something called a relative frequency. A relative frequency is similar to the word proportion, similar to the idea of a fraction. So what you're going to end up with is some decimal value that's going to fall between 0 and 1, And how do you do that? Well, it's similar to a percentage, except a percentage is something like 32%, whereas we're looking for the number that's divided by basically 100.32. So we want this number. So how do we do that? Well, if we want to know the equivalent of 13 as a proportion, then we would divide that by 13 out of how many there are in the entire data set. So we would say something like, I'm going to do it over here, 13 divided by 40. Now, if you go into your calculator and you do 13 divided by 40, you're going to get 0.325. So that would be considered the relative frequency for Democrats in this data. If it's easier for your brain, then if you move this decimal point a couple spots this way, 2 spots specifically, then that would be the equivalent of 32.5%, which means 32.5% of the data or of the people who responded are Democrat. So it's actually quite pretty clear for most students. They remember this stuff in a nutshell, but that is the idea that you're looking for with a relative frequency. We then move to Republican, and there's clearly 18 this time out of 40. So if we do 18 out of 40 in the calculator, we're going to get 0.450. That's the equivalent to 45% of the people that responded are Republican, but we're looking for the proportion or the relative frequency, which is 0.450. We can clearly finish this by doing 9 out of 40 for other. In the calculator, that's going to give you 0.225 as a result. And again, the way to signify to make sure that everything is all good with your result is when you sum all of these up, it should result in a total that's approximately 1. So just a note here, equals means it has to be that number, whereas this symbol, which means approximate, means that it might be a little off. Why might it be a little off? Because you might round one of these numbers from your calculator, and when you add them up, any rounding could throw it off. So you could get like 1.01 or 0.99 or something like that, and that's okay. It's when the number is vastly different than 1 is when you're worried about the result. So in this case, if you add these up, you are going to get a sum that's approximately 1. So this looks like everything has been done correctly. Okay, so in terms of your exams, just be prepared to know the difference between these two things, specifically frequency versus relative frequency. A lot of times on exams, I will ask for one and the student will give me the other. You just have to know the difference between them and how you're going to apply that to the table, which is what you see over on the right.